Welcome back, students. Hope you have understood the concept of binomial distribution in details, whatever I have explained you in the previous lectures. Herein in this lecture, we'll be taking some problems related to the binomial distribution and we'll try to further clarify our doubts if you are having anything. So concept should be very clear after doing this few problems in this section. Now let's take this problem. Okay, if 15 dates are selected at random, what is the probability of getting 2 Sundays? Now this is the question. This is a simple sure shot of binomial distribution problem, and wherein we need to identify n and p, and what is the x is denoted by the number of Sundays. Clear? So we need to understand that what is the probability of getting 2 Sundays if 15 dates are randomly selected. Clear? So in this case, if you solve it, so if we consider that x denotes the number of Sundays, okay, and n equals to, in that case, 15, because randomly we are choosing 15 dates. P is the probability of Sundays in a week. It is nothing but 1 by 7, because there are total 7 days. Out of 7 days, only 1 day is Sunday. Okay, so the favorable response or favorable number of occurrence being a Sunday is 1, and the total days are 7 in a week. So that means in that case Q is nothing but, which will be the non-Sundays, and that will be nothing but 1 minus P, which is 1 minus 1 by 7 is equal to 6 by 7. So this data we are having. Now we can easily use the formula, which is fx. That means, okay, probability of x is the being a Sunday, right? Wherein 15 cx 1 by 7 to the power x multiplied by 6 by 7 to the power 15 minus x. So this is the formula, ncx dot p to the power x dot q to the power n minus x, right? So for all x equals to 0, 1, 2, dot 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 15 trials, whatever 15 days we are taking, this will be the formula, right? So hence the probability of getting 2 Sundays. So hence, as per the question, we are having to find out 2 Sundays. So hence the probability of getting 2 Sundays, that means nothing but x equals to 2. So herein equals to f2, it is nothing but 15c2, or we can say the probability 2, whatever, both the cases it is same. Probability of 2 is nothing but 15c2 1 by 7 to the power 2, 6 by 7 to the power 15 minus 2. So this is coming 105 multiplied by 6 to the power 13 divided by 7 to the power 15. So if you use the calculator, you can use the calculator, it will come approximately 0.29. That means nothing but 29%. So what is the answer? That means, in short, we can conclude that if 15 dates are selected at random, then the probability of getting 2 Sundays is 29%. Hope you have understood and it helped you to clarify your doubts. Let's see the next problem. Now in this problem, it is here we need to find out the mode. So what is the mode of binomial distribution if mean is 10 and the standard deviation is √5? If you remember, when we are explaining the concept of properties of binomial distribution, we said that binomial distribution is nothing but it is having the bimodal concept. That means it may be unimodal, it may be bimodal also, depending upon n plus 1 dot p multiplied by p, what is the value of that, whether it is an integer or non-integer. Clear? So based on that we can find out the mode value. So in this case it is given that mean mu equals to n into p, which is 10, and standard deviation is nothing but it is mentioned, which is root over npq. As per the property and the formula we know, it is given root 5. So I can find out squaring both sides, npq equals to 5. So both the cases, solving both the cases, we get n equals to 20 and p equals to half. Correct? So it is np equals to 10. I'm putting np is equal to 10. So 10q equals to 5. Correct? Correct? 10q equals to 5. So q equals to 1 by 2. So hence p is equal to 1 minus q, which is half. Clear? So similarly we can find out the value of n also, because putting value of p half out here, n equals to 10 into 2, so it will be 20. Clear? So we have calculated and found this result. Now to find out the mode, we need to understand what is the value of the largest integer. So mode equals to nothing but the largest integer contained in n plus 1 into p. Correct? So now n plus 1 into p is nothing but 20 plus 1 multiplied by half. So this is 21 by 2 is nothing but 10.5. So 10.5 is a non-integer. So as per the property, if I know if it is a non-integer, okay, then the largest integer contained in that is nothing but 20 plus 1 into half, nothing but largest integer contained in 10.50. So largest integer contained in 10.50 is 10. Clear? So I can easily say the mode value of the given data is nothing but 10. Let's consider this problem. This is a typical problem and the different problem. Here it is saying if x and y are two independent binomial variables with parameters 6 and half and 4 and half respectively, what is the probability of x plus y which is more than 1? Now you please understand here in this case we are going to use the additive rule, right? So because in both the cases p value is same, only n value is different, right? So in that case let's assume z is equal to x plus y, and using additive property, okay, or additive rule, whatever you say, z is also a binomial distribution with parameters, okay, like 6 plus 4 equals to 10, which will be n, nothing but this is n1 plus n2, correct, and half, which is nothing but p in short, right? So now if I try to find out p, z is more than or equal to 1, as whatever we need to understand this one, because x plus y equals to z we have considered here, then we can write it is nothing but 1 minus probability of z less than 1. Correct, na? Correct. So if I'm saying probability of, I need to find out probability of z which is more than 1 here, so I can say 1 minus this side. Correct. probability of Z will be the value. Clear? So in that case 1 minus probability of Z less than 1 is nothing but probability Z equals to 0, less than 1 0, because we have only 0 to 1 value. Clear? Now we need to find out the probability of Z value and we need to minus it from 1. So this is nothing but 10C0. Why? Because n is 10 now. 10C0, P which is half to the power 0, Q which is half to the power n minus x, that means 10 minus 0. So this is a binomial distribution formula and these things. So what I'm getting, 10C0 is nothing but 1, half to the power 0 is 1 as per the indices rule, and I'm getting half to the power 10. So half to the power 10. So this is nothing but 2 to the power 10 minus 1 divided by 2 to the power 10, which is nothing but 1024 minus 1, 1023 divided by 2 to the power 10 is nothing but 1024. So this is the answer. It means what? Very simple. Using the additive rule, we have found out the solution of this problem, and the problem has given as like that if x and y are two independent binomial variables with parameters 6.5 and 4.5 respectively, then the value of p xy, which is more than 1, will be 1023 divided by 1024, which is very much close to 1. Clear? Hope you have understood this problem, and in the next problem we'll try to solve a different type of concept. We'll try to find out the value of expression of the binomial distribution. Let's take this problem. Find the binomial distribution for which mean and standard deviation is given 6 and 2. Please understand. Herein the question is I need to find out the binomial distribution equation or binomial distribution expression, I will say, okay, not the equation. So in that case what will happen, x will be there because x is not given. So that equation we need to find out, or the expression we need to find out, wherein standard deviation and mean is given. Now if I ask you why standard deviation and mean is given, without that binomial distribution expression I can't write. Yes, I can't write, but that will be a binomial distribution formula. As I told you that binomial distribution is the biparametric, that I need to find out n and p. If I find out the n and p, then the expression is complete, correct? And then only the unknown will be the x. Okay, so as per that the success of certain x, we can find out any kind of details or the solution or the I will say the value, right? So in this case I need to find out the binomial expression. Here it is given that mean mu is nothing but n into p, which is 6. I'm sorry, 6. Mean is given 6 and standard deviation is given 2, and standard deviation is nothing but root over npq, which is given 2. Clear? So I can easily say variance, which is nothing but standard deviation square, which is nothing but npq, equals to 4. Any doubt? So I am just writing this is equation 1 and this is equation 2. So solving equation 1 and equation 2, we get np6, npq is equal to 4. So q equals to 4 by 6, which is 2 by 3. Okay, hope you have understood, right? Now the moment I have got q value, hence we can calculate p value, which is 1 minus q, which is 1 minus 2 by 3, which is nothing but 1 by 3. Clear? Easy. So now we have got p value, and also we have got the q value, and also we have got the now the n value also. Oh no, so we do not need to find out the n value now. Okay, so we have got the p values and all, right? Clear? Now what is the value of n? So now we can calculate the value of n. So n p q equals to 4, n multiplied by 1 p value is 1 by 3, q value is 2 by 3 equals to 4. So 2 cancels out. So n value is 339, 9 multiplied by 2 equals to 18. So as I said, we need to find out the n value, which is 18, and the p value, which is 1 by 3, or similarly we can indirectly calculate q value, which is 2 by 3. So r, all unknowns are done. Clear? Now I can write the expression. So now I can find out fx, or we can write probability of x, whatever you can write, that's not a big problem, is ncx p to the power x and q to the power n minus x. Now in this case I can write it is nothing but n is 18, cx, p is 1 by 3 to the power x, q is 2 by 3 to the power 18 minus x. This is for all x equals to 0, 1, 2, dot 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 18, up to 18. Clear? Hope you have understood. And this is the required binomial distribution expression. Good. Hope you have understood. All four problems are completely different of each other, and hope the concept now it is very clear to you. Hope you have understood, enjoyed the binomial distribution section. So in the next section, and in the next section we'll be talking about some Poisson distribution and how we can understand some properties, and we'll do some problems related to the Poisson distribution.